Hey, pre-calc, this is trig day 6. We're looking at some more quadratic equations today. So in yesterday's notes on trig day 5, we started an initial discussion of solving some quadratics. When we have a quadratic trig equation, first thing we're going to ask ourselves is, can we factor it? And if it's not factorable, which we might encounter today at some point, well, then we're going to use some other techniques of how we know how to solve quadratics. So we're going to solve this over 0 to 2 pi, like we've seen in the solving equations unit so far. And I want you to round to the nearest hundredth when necessary. And that will kind of be a big deal because it's not always necessary to have to round your answers. Okay, sometimes you get nice answers because the reference angle is nice. And then, in other cases, we may not have to do any rounding at all. But in this very first example, you'll see we have 3 cos squared minus 5 cos x equals 2. With quadratics, we know that the goal to start is to always set it to 0. So that's the first step. Go ahead and move the 2 over and then consider, can I factor this at all based on the fact that we have that lead coefficient of 3? So if we think of this as like 3x squared minus 5x minus 2, we'll, I think, initially start by considering, can it factor based on the fact that 3 cos x and 1 cos x are the only things that multiply to 3 cos squared? Can I place the factors of -2 in either location such that the middle term becomes -5 cosine x? And it turns out if I put the -2 over here and the +1 over there, there's really only 2 options to consider. It's either this way or the other way. And I guess you could switch around the plus or minus too, but notice how the outside would give you -6 cos x. The inside would give you +1 cos x. -6 plus 1 is the -5 cos x as we have in the middle. So I'm confident that we've now factored that correctly. And now that we have it factored, you can draw the wall and then set each side equal to 0. So on the left side, we get that cosine x equals, subtract the 1 over, so -1 over 3. And then over here, if I set this equal to 0, we get cos x equals +2. Okay, let's start with the right side actually. Cos x equals +2, that's 2 over 1. And I think initially we look at this and we just start right away by asking ourselves, where is cosine positive? Which quadrants? Let's draw some triangles. But you're really going to want to take an extra 5 seconds every time you get cos x alone and say, is it even possible to continue? Notice how the adjacent is going to have to get labeled as 2. And when I put that over 1, that the hypotenuse is smaller than the adjacent. Cos x can never equal 2. There are no solutions to this side of the equation when I solve and set it to 0. So for cos x, if you ever get something outside of that range from -1 to +1, you got to stop yourself and say, nope, no solution. It's a little tempting though, because we have triangles with sides of 2s and 1s, but not in those specific locations. Okay, so be careful with that side. Can I do cos x equals -1/3? Is it possible? Well, what I just said a minute ago is that it has to be within -1 to +1, and certainly -1/3 fits that pattern. But I'm thinking we don't have a triangle with a hypotenuse of 3. So this one's going to be one that we have to use the calculator to get the reference angle. But before I do that, let's ask ourselves, what quadrants am I in? Cosine's negative in quadrant 2 and quadrant 3. So we're going to go ahead and draw triangles in those quadrants. You don't really even have to label the sides. I mean, if you want, the -1 goes here, the 3 goes here, but there's no special pattern for the other missing sides and therefore the reference angle. So to find the reference angle, here's what you're going to type into the calculator. The reference angle is cos inverse, that's how we're going to get the x alone, of +1/3. If you type in the negative, you get answers that start to get very confusing. And I hope by now we've done enough practice that you're like, yep, I kind of remember Mr. All keeps telling me when I do the cos inverse or sine inverse or tan inverse step, this has to be positive. Why can I ignore the negative? The negative just tells you which quadrants you're in. We don't need the negative when I do cos inverse of 1/3. And oh, by the way, double check that you're in radian mode because my answers have to be in radians. Cos inverse of 1/3 is, hey, this is as easy as 1/2/3. It's a reference angle of 1.23, which is fun because we like when answers are 1, 2, 3, but 1, 2, 3 is just the reference angle. So as a reminder, if halfway around is pi, how do I get the answer if I'm in quadrant 2? Well, in quadrant 2, to get this angle, It's pi minus the reference of 1.23. So pi minus the reference angle. Let's say pi minus that 1.23 is 1.91. That is one of the answers. When you move over into quadrant 3, how do I get the answer? You take your half circle, pi, and add on the reference angle. So here it's pi plus, and pi plus the reference angle of 1.23 is 4.37. We'll do a little bit of calculator checking today, but maybe I'll skip this one to check. Yeah, I mean, certainly if I type this into y equals, I'm going to see that it crosses the x-axis at 1.91 and then also 4.37. Okay. So it takes a little while to get used to, especially when the angles are not nice, but the calculator's doing most of the work. We just have to know, how do I take this reference angle and apply it appropriately in the quadrants, where in this case, cosine is negative. Okay, let's do another one. Number 2. We're going to solve sine squared minus 5 sine x plus 3 equals 0. Okay. So when I go to solve this, at least there's no lead coefficient like there was in the last one, right? The last one had a 3. But in this one, I have to think about, well, what adds to -5 and multiplies to 3? And the very quick answer to that is nothing. So this is our first example of a quadratic that is not factorable. And since it's not factorable, we have to use another technique to solve it. And that other technique that we're going to use is we're going to solve using quadratic formula. So I hopefully you remember that. Usually it's x equals negative b plus or minus the square root of b squared minus 4ac all over. Alone, I'm getting sine x equals negative e, which is positive 5, plus or minus the square root of -5 squared minus 4 times 1 times 3, all over 2a. Okay, so the coefficients a, b, and c are in the same spots. A is the coefficient of the square term, b is -5, c is 3. But this is not what x equals. It is what sine of x equals, which is an important distinction to make. Very carefully make sure you simplify that number under the radical. So what's that, 5 plus or minus? This is going to be radical, let's see, 25 minus 12. It's radical 13 there, all over 2. And at this stage, what we need to do is we need to separate this into the two cases that we have. We have on one hand, sine x equals 5 plus radical 13 over 2. And on the other hand, sine x equals 5 minus radical 13 over 2. What I want to do in each example is figure out what is sine x equal to as a decimal. Because I want to figure out, I don't know, is this a positive amount? Is it a negative amount? You know, you probably know what it is, but let's just type in first and foremost, what is 5 plus the square root of 13, hit enter, and then divide that by 2. That's 4.302 ... So this number over here is a decimal. It looks like that. If you want to type it in all at once, by the way, you can do a fancy fraction, right? 5 minus the square root of 13 and then divide that by 2. That's 0.697. Okay, so now that I have those decimals established, here's what I'm going to tell you about this side. Sin x equals 4.302 has no solutions. We can't get a solution there, right? Opposite over hypotenuse. Can the opposite be 4.302 where the hypotenuse is that lonely one? No. So just like we talked about for cos up above, if the ratio for sine is bigger than 1, it's no good. Which means that on this side, we will get two solutions. Those solutions are going to be in quadrants 1 and 2. Why are we in 1 and 2? Because sine is positive in those two quadrants. All right, so how do I get the reference angle? We don't have the reference angle yet. We have what sine of x equals, but the reference angle is second sine of this 0.697 number. So that gives you a reference angle of 0.77. So we have to take that reference and apply it to the two quadrants where we have answers. One of them is quadrant 1, the other is quadrant 2. Quadrant 1 is nice because the answer is the reference, 0.77. As a reminder, in quadrant 2, halfway around is pi. So it's pi minus the reference. So pi minus that 0.77 is 2.37. And these are the only two answers. I'm going to show you just really quickly for this one how you can check it on the calculator. If you go to y equals, you're going to type in sine x and then close parentheses, square it, minus 5 sine x, and then plus 3. All right, I'm going to graph. Hopefully my graph shows me these two solutions here. By the way, when I hit graph, my window is set accordingly. And notice how, yeah, I only see a solution here and a solution there. Hopefully that first solution is 0.77. I'm going to check it out. Second trace, I'm going to calculate the 0 there. Or you know what? I'll check this one on, just so I'm closer already. 2.37 should be this answer if I go to the left and to the right of it. And hit enter, and fingers crossed, there it is, 2.37. So you can certainly, if you're unsure, like, oh, these answers look kind of crazy, I don't know, check them on the calculator, see what you get. All right, let's do one more of these just to make sure we're on the right track. I know this extra layer of quadratic formula can be a little intimidating at first, but of course, with more practice, you will get used to it, just like anything else. All right, last one we got is tan squared minus 4 tan x is equal to 1. Okay, first and foremost, just like in the first example, subtract the 1 over. Got to set this to 0 if you want to be able to consider how to solve the quadratic. So when I subtract the 1 over, is there anything that adds to -4 but multiplies to -1? Nothing I can think of. So just to get a little bit more practice with the quadratic formula, here we go. Tan x equals negative b positive 4 plus or minus the square root of -4 squared minus 4 times 1 times -1. It's a little odd singing in a room by yourself, but I guess it's not too crazy. I don't know. Probably sing in the car by yourself. All right, so here's what we got. We've got tan x equals 4 plus or minus the square root of, that's 16, and then that would multiply to a positive 4, right? -4 times -1. 16 plus 4 is 20, all over 2. Once you have that, just like I did up above, I shouldn't say up above, but on the last page, separate it. 4 plus radical 20 over 2, and tan x equals 4 minus radical 20 over 2. Then what I like to do is figure out what those two things are as decimals. Here we go. Going a little fast here, so you got to keep up. Okay. Alpha y equals, let's see, 4 plus the square root of 20 divided by 2 is 4.236, dot, dot, dot. And then over here, I can actually just go and highlight this and change the middle sign to a minus, or minus radical 20 over 2 is negative 0.236, dot, dot, dot. Okay, we got those two. So remember what happened for sine before, where I said, ups, that's bigger than 1, no solution. It's okay for tan. Tan has no restrictions. Tan can be a billion on this side, okay? So it's only restricted to be within -1 to 1 is if it's sine and cos. That's the only issues we have. But for tan, this is a positive amount. So we're going to get answers in quadrants 1 and 3, where tan is positive. Let's figure out the reference angle. The reference angle is second tan of, go back and just make sure you get the right one, the 4.23 number. The reference angle is 1.338, dot, dot, dot. Okay. So we need a quadrant 1 answer, and we need a quadrant 3 answer. Quadrant 1, the answer is 1.34 to the hundredths place. Reference angle is your answer. In quadrant 3, it's pi plus the reference. Pi plus that reference angle is 4.48. So we've got 2 of the answers. We're going to get 2 more over here. Get ready for it. Tan is negative in quadrants 2 and 4. Make sure when you type in tan inverse to get the reference angle, you do positive 0.236, blah, blah, blah. The negative just tells you the quadrants, but you're not going to get a good reference angle if you use the negative in there. We'll learn later on in the trig unit why that's the case. So here's what I'm going to do. I'm going to get this negative 0.23 number, but since I'm really making a big deal about making that positive, just multiply it by -1. Perfect. Now it's positive 0.236. Tan inverse of that is 0.231. And I realize that's weird because it's so close to what we were doing tan inverse of. Okay, but don't get too thrown off by that. We have a quadrant 2 and we have a quadrant 4 answer on this side. Quadrant 2 is pi, but minus the reference. Here we go. Pi minus the reference is 2.91. And then quadrant 4, remember, is full circle 2 pi, but minus the reference. 2 pi minus, just make sure you get the reference, 0.231, is 6.05. And I won't graph this one right now, at least. Maybe we'll do some more graphing in class. But those 4 answers would be correct if I were to type in the original to y equals and see where it hits the x-axis. Okay. I know this is an intense process. I promise you we're going to do more practice with it. So please, if you have questions about anything from the video, go back and rewatch it again. And please check in with me next time we're in class. This way, hopefully we can address those issues and do more practice like it. All right, that's it for now. Have a great rest of your day.